Hi everybody, I hope everything's going well today. Sorry I wasn't there to help you with your first balancing of equations, but I gave you this little worksheet to start on in class and to take home for homework. So let me work through a couple of these problems with you, and hopefully you'll see that balancing equations can be a little tricky, but it's not impossible. One of the things I do first is I try to save balancing things like hydrogen and oxygen till the end of the process because they usually appear more than one time on each side of the equation, and as you start to adjust coefficients, their numbers are going to change. So I try to find something that really stands out in the equation first. So I'm really seeing this iron over here, and I'm seeing the iron on this side. I'm also seeing that we have a polyatomic ion. We have sulfate here, and we have sulfate on the other side. I don't like to break those apart and think of them as a sulfur and four oxygens. I want to keep the sulfate polyatomic ion as one thing. So here I see I have one ion on this side, and here I see I have three ions on that side. So instead of counting all the individual atoms, I'm going to look at them as one thing. So let's start balancing, and if you make a mistake, that's no big deal. That's what pencils are for. You can just erase them. So I'm going to look at the irons first, and I see on this side that I have 2, so I'm going to stick a 2 as a coefficient on that side. Now I see that my irons are balanced. Now I'm going to look at the sulfate polyatomic ion. On this side there are 3, because remember that 3, subscript 3 after the parentheses means you have 3 of whatever's inside the parentheses. So I'm going to put a coefficient of 3 on this side. So now my irons are balanced. I have 2 on this side, 2 on the right. I have 3 sulfate ions on the left and 3 that were already there on the right. Now I'm going to add up the hydrogens and see how to balance those. On the left here I have 3 times H2. So that gives me 6 hydrogens on this side, and I have H2, which means I only have 2 on the right. So all I have to do to make that 6 is put a coefficient of 3 here. And so that means we have a coefficient of 1, which you really don't have to show on a balanced chemical equation because you're already assuming that there's 1 there. So our coefficients there should be 2, 3, 1, 3. The next one is kind of tricky. And the reason it's tricky is because just by looking at it, and you'll get the hang of this soon, I can see right away that I have an odd number of oxygens. I have an even number of oxygens on the left, but an odd number of oxygens on the right. And you will never be able to balance an even and an odd number. So we have to do something to make them both even. So keep that in mind, and I'm going to show you as we go through what we're going to look for. So again, that'll handle itself at the end. Let's look for what's obvious. So if we see on the left here we have 2 carbons and we have 6 hydrogens, let's fix that on the right. So let's go ahead and start putting coefficients in and see what happens. So I'll take a 2 on the carbon dioxide to balance the 2 that's on the left-hand side, and I'll put a 3 in front of the water to balance make 3 times 2, 6 hydrogens to balance the 6 hydrogens on the left. Now let's see what happens. Let's count up the oxygens. On the left-hand side I have 2. On the right-hand side I have 2 times 2, which is 4. 3 times 1, which is 3, so I have 3 plus 4, which is 7 oxygens on the right. So we're never going to be able to balance that 2, that even number, with that 7, that odd number. So that tells me right away that I'm going to have to double anything that has the odd number in it, and that's this coefficient here. So what I'm going to do, instead of writing a 3 there, I'm going to change that to a 6. And I'll do that in a different color so you can see what happens. So I'm going to double this odd number 3 to a 6. Now let's see what that does to my hydrogen count. Now I have 6 times H2, which gives me 12 hydrogens on the right. I have 6 hydrogens on the left. All I have to do is put a coefficient of 2 in front now. Now my hydrogen count is good. Now I have 2 times C2, which gives me 4 carbons on the left. All I have to do is go over and change that coefficient on the right. Now that gives me the 4 carbons on the right. Now that coefficient 4 also gives me 4 times 2 oxygens on the right, which now changes the count to 8 for the carbon dioxide, 6 times 1 for the water, so 6 plus 8 gives me 14 oxygens on the right-hand side. And that's easy to fix on the left-hand side here. We have O2, so all I have to do is put a coefficient of 7 in front of that. So my coefficients are 2, 7, 6, and 4 for problem number 2. And I know that was really confusing, but once you start doing it, they can kind of be fun. Okay, let's look at problem number 3. Remember I told you to watch for odd numbers, and as soon as you see an odd number, the best thing to do is double it. But that's only if it's odd on one side and even on the other. So if I'm looking at the potassiums here, I see I have 1 on the left and I have 3 on the right. Well, 1 and 3 are both odd numbers, so that's not going to be a problem. When I look at my phosphate groups, remember I'm going to keep it as a single thing. I'm not going to think of it as a phosphorus with 4 oxygens. I'm going to think of it as one phosphate. So when I look at the phosphate groups, I see that I have 1 on each side. So what I'm going to do is tackle the obvious thing, and I'm going to look at that potassium, those 3 potassiums on the left. And I'm just going to stick a coefficient of, 3 on the right. I'm going to stick a coefficient of 3 for the one on the left. Now let's see what that does to my hydrogen count. I have 3 hydrogens here plus 3 on this the potassium hydroxide, so it gives me a total of 6 hydrogens on the left. I have 2 on the right, so if I put a coefficient 3 here, that's going to give me 6 hydrogens on the right. So the hydrogens are good, the potassiums are good, the phosphates are good. Now let's check out those oxygens. Here with the potassium hydroxide, I have 3 times 1, which gives me 3 oxygens here. Remember, I'm not going to look at those oxygens because I'm treating that phosphate as one thing. I am going to come over here and look at these oxygens, and I have 3 times 1, which gives me 3 oxygens on the right. So my coefficients for this are going to be 3, 3, 1, which you don't have to write, 3. And that gives me my balanced equation. Okay, for the next problem, I see I have a single 10 on each side, and I've got an odd number of oxygens on the right, and I have an even number of oxygens on the left. So you're never going to be able to balance an odd number with an even number, so the easiest thing to do is double the odd number. So I'm just going to stick a 2 there because I can always change it later if it doesn't work out. Now I see I have 2 oxygens on the right, and that balances those 2 oxygens on the left. I have 1 tin atom on the left and 1 tin atom on the right, so I'm not going to worry about that. But I have 2 times 2 hydrogens on the right, which gives me 4. Only 2 on the left, and I can fix that easy by putting a coefficient of 2. So my coefficients for each of these is going to be 1, 2, 1, 2. Okay, let's look at number 5. Number 5, we're reacting ammonia with oxygen to get nitrogen monoxide and water. So let's do our atom count. We have 1 nitrogen on the left, 1 on the right. We have 3 hydrogens on the left, and we've got 2 on the right. So remember what I told you about that odd and even. You're never going to balance an odd and an even number. So the first thing you need to do is double the odd. Right now that gives us 2 nitrogens and 6 hydrogens. So we can fix that by putting a 2 in front of the nitrogen monoxide, and we can get the 6 hydrogens by putting a 3 in front of the water. Now let's see what it does to our oxygen count. We have 3 times 1, which is 3, and then we've got 2 here, which gives us 5, and then we've got our 2 oxygens on this side. So now we have that problem again with the odd and even number. So find out what's making it odd, and we're going to double that one. So it's got to be this water when we put the coefficient 3 there. So I'm going to change the coefficient, and I'm going to double it, and I'm going to make it a 6. So when I put 6 there, that gives me 12 hydrogens, which I can fix on the other side by changing that 2 to a 3. No, a 4, sorry. So now I have 12 hydrogens on the left. I've got 6 times 2, 12 on the right. Now let's go back and fix the rest of those coefficients. And that's what your pencil's for, so you can erase those things. So 4 nitrogens, I'll put the 4 here. And now let's count up our oxygens. Now I have 6 times 1, which gives me 6 on the water. 4 times 1, which gives me 4 on the nitrogen monoxide. So I have a total of 10 oxygens on the right. All I need to do is put a coefficient of 5 on the left, because that's 5 times 2, gives me 10 on the left. And we're done. For this next one, we've got 2 polyatomic ions. Remember, we're not going to break them apart into individual atoms. We're going to treat them as one thing. So I'm going to pay attention to the polyatomic ions on each side. So on this side, I have 1 nitrate group. I have 1 carbonate group. On the right-hand side, I have 1 carbonate group, and I have 1 nitrate group. So it looks like the polyatomic ions themselves are balanced. But when I look at the potassiums, on the left there's 1, on the right there's 2. So that means I'm going to have to add a coefficient 2 in front of that potassium nitrate. So let's put a 2 there. So now the potassium count is good, but now I have doubled the amount of nitrates on the left-hand side. So that means I need to go to the right-hand side and double those as well. And I can do that by putting a coefficient of 2. Now, in the PowerPoint presentation that I put for the day in review, we talk about how you can never use subscripts to balance a chemical equation. The reason that this is written as HNO3 is because the nitrate group is a -1, the hydrogen is a +1, and so the sum of those oxidation numbers equals 0, so that's balanced in itself. I can't come along and change the formula by giving 2 nitrates by putting it in parentheses and adding a subscript. That's just not allowed, so don't do that. We can change the amount by putting a coefficient. So now the nitrates are good on both sides. The potassiums are good on both sides. Let's see what happened to the hydrogen. I have 2 times 1 hydrogens on the right, and I have 2 hydrogens on the left, so I'm balanced. So my coefficients are going to be 2, 1, 1, 2. And again, you don't have to write the ones there because it's assumed if you have something there, it's assumed that you have 1. Okay, let's tackle the next one. I see on this side we've got 2 bromines on the left. I'm sorry, 2 borons and 6 bromines on the left, 1 boron and 1 bromine on the right. So we should be able to balance this fairly easily too. Look, there's 1 nitrate on the left and 3 nitrates on the right. Let's take care of the bromine first. 2 on the left, 1 on the right. Let's put a subscript 2 there. That takes care of those 2 bromines, but it also doubles the number of nitrates. We had 3, now we have 2 times 3, which means we have 6 nitrate groups on the right. If you go back to the left here, we see we only have 1, so I'm going to put a coefficient of 6 in front of the nitric acid. So that gives me 6 hydrogens on the left. When I look over on the right, I see I only have 1. If I put a 6 there, that takes care of those 6 hydrogens. It also takes care of those 6 bromines, which we see we have over here with the boron bromide, sorry. So our coefficients here are 1, 6, 2, 6. Okay, let's check out the polyatomic ions on the next one. I have 1 sulfate on the left, and I've got 3 on the right. So let's take care of the obvious things first, and let's put 3 in front of the lithium sulfate. Now that gives me 3 sulfate groups, but it also gives me 3 times 2, 6 lithiums in that on the left-hand side. And I can take care of that easily by putting a coefficient of 6 on the right-hand side. Now I have the 6 lithiums, but it also affects the fluorine, so now I have 6 fluorine atoms on the right, which means I have to come over to the left, and I'm going to put a coefficient of 2 in front of this group. So 2 times 3, my fluorines are balanced. I also have 2 borons, which gives me 2 on this side, and we're already balanced. So our coefficient now is 2, 3, 1, 6. For the equation with ammonium phosphate, let's look at the leads first. I see on the left-hand side we have 1 lead, and on the right-hand side we have 3. So let's balance that by putting a 3 on the left. Now that I have the 3 leads, remember that 3 means I have 3 of everything that follows it. So that means I have 3 times 4 of those nitrite groups. So that means I have a total of 12 nitrates. So I have to put a coefficient of 12 on the right-hand side. That also gives me 12 of those ammonium ions. Over on the left-hand side, I have 3 total, so I'm going to put a 4 coefficient on the left. Now that gives me 4 times 3 of the ammonium ions, which is 12, but it also gives me 4 phosphate groups. When I look over on the right-hand side, I already see I have those 4 phosphate groups. So now my leads are balanced. I have 3 on the left, 3 on the right. I have 4 phosphates on the right, and I have 4 on the left. I have 12 of those ammonium ions on the left, and I have 12 on the right, so we're balanced. So our coefficients for this problem would be 4, 3, 1, and 12. Okay, for our last problem here, let's do our count. We have 1 selenium on the left, we have 1 on the right, we have 2 oxygens on the left, we have 2 on the right, so those look good. It's the chlorine count that's off. So we have 6 chlorines on the left and we have 2 on the right. So all we have to do to this one is add 1 coefficient, which is a 3. Everything else is in line and balanced, and so the only coefficient we have here is that 3 on the chlorine. So your coefficients would be 1, 1, 1, and 3. And again, you could put them in there or not. It doesn't matter because we just assume if it's not there that there is 1. So I hope this helped you out. Practice, that's what this is about mostly. Watch the day in review. That's the lecture I would have given you today had I been there. And look at some of those helpful hints and rework some of these problems, and we'll get you some more tomorrow. If I'm not too snowed in, I'll be there, but it looks like you've got another sub day. So I hope that you're doing well for Mr. Webb. He's a really good guy. And definitely I'll see you on Friday.